Hello everyone, I'm Kirti and my partner is Anana. We will be presenting to you our project development of machine learning models for early stage Parkinson's disease prediction using voice recording data. So coming to the outlines, I'll be talking about the motivation, why we have used voice data, the challenges and approaches to address the machine learning model development challenges, and Anana will be telling about the performance comparison between different models, the results and conclusion. It is estimated that globally there are 10 million individuals affected with Parkinson's disease. What is Parkinson's disease? It is a neurodegenerative disorder that affects the movement, balance and coordination in the body. Some of the motor symptoms are uncontrollable tremors, slow movement and muscle rigidity. What are the non-motor symptoms? They are cognitive impairment, speech impairment, mood disturbances, and others. Why PD remains uncertain is because the cause is not known, and early detection is the key to improving patient outcomes and slowing the disease progression. The reason that we have used the speech data is because it is commonly and severely affected feature in the early stages of Parkinson's disease. The other the other features that it is affected is we can detect by because it is vocal reduces the vocal intensity, imprecise articulation, and speech monotony is shown in the individuals affected with Parkinson's disease. So that is why voice analysis is a promising tool because it is non-invasive, it is cost-effective, and can be monitored remotely using apps or digital devices. What are the challenges that we will face in machine learning models for Parkinson's disease detection? The first one is class imbalance. The Parkinson's disease samples can outnumber the healthy controls, so risking the bias on the model prediction. The second one is feature selection. There are many irrelevant or redundant features that can reduce the model accuracy. Third one is the model interpretability. That is clinically useful models should provide correct and understandable decisions for the healthcare professionals. How did we address these challenges? Are for handling class imbalance, we applied SMOTE, that is synthetic minority oversampling technique, to balance the data set and reduce the prediction bias. Second one is recursive feature elimination method to improve the feature selection and retain only the most relevant features. Third is we used three model trained and compared three models, that is random forest, SVM, and KNN with and without recursive feature elimination for ensuring robust model performance. So coming to our project, the most important requirement is the data set. So we have selected the affected and the healthy subjects data from UCI machine learning repository. It is why we have selected is because it has an extensive range of speech related features. It comprises of 195 voice recordings from 31 participants with imbalanced class distribution, that is 23 affected patients and 8 healthy subjects. I'll hand over to Anana for further explanation.
Thank you, Kirti. So for handling the data imbalance for our data set, we used a smart technique. So this actually generates synthetic examples for the minority class. And here the minority class is healthy patients. We can see the class distribution before and after the smart technique. So here's the feature selection. We have used the recursive feature elimination technique for improving and getting the most important feature. This technique actually selects the subsets of most significant features by recursively eliminating the least important one. If we look at this right graph, we can see there are 10 selected features are most important for the random forest model that actually we used for the classification. For improving the model performance, we have also used hyperparameter using research CV. Yeah, you can turn back. So for the confusion matrix among different types of models such as random forest, SVM, and KNN with the feature selection, we can see that random forest performs better because it only misclassified two classes compared to the SVM and KNN, where SVM misclassified four classes, and for the KNN it misclassified three items. So overall, random forest outperformed with 0.98 accuracy. If we compare using the feature selection and without the feature selection, we can see the four metrics here: accuracy, precision, sensitivity, and F1 score. Accuracy measures the overall correct prediction, whereas precision minimizes the false positive, and recalls ensures the true PD are identified properly. F1 scores balanced the recall and precision. If we can see that a random forest, it outperformed all the models because the precision score is 0.9487, whereas for the other model, it actually reduced the value lower than between 86 to 90. So here is the ROC curve between smart with RFE and without RFE. Even if the accuracy for the with feature selection is better, we can see that this curve shows that without feature selection model, we get the better ROC curve, and it shows the ranking capability of the model. So here we can compare that our model outperformed with other literature studies that actually using the same voice data set and using different classification model. So here's the conclusion and future work. We have successfully identified and applied the different types of machine learning models such as random forest, SVM, and KNN for detecting the Parkinson disease at an early stage. We have used a feature selection using the recursive feature elimination, and also class imbalance has been handled by SMOT technique. The random forest achieved the highest accuracy with 94.87, and in the future we plan to apply the CNN or RNN, different types of deep learning model in a different data set for better performance. Thank you so much for your attention.
Thank you.